So let's do this question here. Find the x coordinate of P, this point right here, in terms of A, and they're talking about this A, I guess, so that a rectangle OAPB has a minimum perimeter. Okay, so to do this, we got to figure out this point right here, and this point A is going to be x and 0 because the y value here is 0. And this point B is going to be 0 and y. And therefore, the perimeter of here is going to be, the perimeter is going to be 2x plus 2y. So if that's from here to here is y, so that's y, and from here to here is x. This is x. And what we're going to do now, we're going to write 2x plus 2, and y is represented by this, the equation. So since we have the equation, then we could, instead of y, write what the equation is. So 2a e to the minus x, and that's now the perimeter of this red shape right here, or red rectangle. So if we want to find the a value, if we want to find the a value right here that makes this rectangle have a minimum perimeter, then we have to take the derivative of p. So p prime equals, this is 2x, so therefore the derivative of that is 2 plus the derivative of this 2a is a constant, so it's going to be 2a, and the derivative of e is still e to the negative x. So if y equals e to the f of x, then y prime would be e to the f of x times f prime of x. So basically this here, the derivative of that is e to the negative x times f prime, and this is f, and the derivative of negative x is -1. And now we have 2, that's -1 times 2, that becomes negative. So instead of a plus here, we have -2a e to the negative x. And what we need to do now, we need to set that to 0 so we could find the critical value. And the critical value is the value that gives us a maximum or a minimum of the perimeter. I'm going to move this whole thing, -2ae to the negative x, to the left side, so it's going to become positive. So 2a e to the negative x equals 2. Now I'm going to divide both sides by 2. As a matter of fact, I'm going to divide both sides by 2a. And therefore, I have e to the negative x equals 1 over a, because the 2 reduced 1, 1. What I'm going to do here to get rid of the negative exponent, I'm going to change this to 1 over e to the x. I bring the e down, flip it, and then the exponent becomes positive, equals 1 over a. And what happens after, I could flip all of this, you know, like the roasting chicken, you know, so it could flip all of it together. And what I'll have e to the power of x equals a. So all of this rotated together, and that's what we have. So this becomes e to the x over 1, and this becomes a over 1, and that's what we have here. Now to solve for x, we're going to ln both sides. So when we ln this, the x will drop. So x ln e equals ln a. Of course, ln e is 1, and therefore x equals ln a, and therefore we have represented X in terms of A, and that is the X value that will give me a minimum for this rectangle, or a minimum perimeter for this rectangle. And that's that. Keep on supporting. As always, thanks for watching. Till next time, bye-bye.